Sir.
Okay. Okay, yeah, sure. So I think we can continue, right?
Yes, please.
Okay. So good. So let's continue. So that is the basics for the remainder theorem. So the whole idea is now we give you a dividend with a higher degree, and then we give you the divisor or the factor. Good. Now they can ask you to find the remainder when this quadratic expression or cubic expression is divided by this linear expression. Now, the only way is you go through the long division before you are able to identify your remainder at the end, which is very tedious because you don't need to go through all that stress. So the remainder theorem is a way to even determine the remainder before you even do the long division, or you choose not to do the long division at all. So you pick the divisor that has been given to you or the factor. Now equate it to 0. When you equate it to 0, it means that you are going to find the value of x. Just pick the number, cross it to the other side of the equal to sign. So you're going to have x is equal to a number. Good. Now that x is equal to a number. When you pick the number and you fix it inside wherever you can find x within the function, the number you get is the remainder you're going to get. That is all about the remainder theorem. So now we can conclude that when the polynomial 2x cubed minus 3x squared plus 4x plus 5 is divided by, good. So now let's use this as an example. So find, this is how the question goes. Find the remainder. Find the remainder when 2x cubed minus 3x squared plus 4x plus 5 is divided by x plus 2. Very, very simple. It's divided by x plus 2. Divided by x plus 2. Good. So now, under normal circumstance, we are supposed to go through the long division and then find the remainder. But it looks very tedious. So now, for revision's sake, I have 2x cubed minus 3x squared plus 4x plus 5. Now it is being divided by x plus 2. So I always pick the x first. So if I always pick the x first, now this is what I have. So x is going into this guy, 2x squared. 2x squared. Good. 2x squared. Now I have 2x squared times x is 2x cubed. Plus, now 2x squared times 2 is what? 4x squared. So 4x squared. Now I subtract. So here, my subtraction sign, and then I underline it. Now, this negative is affecting these two. So it makes it automatically negative 2. So negative 2 and plus 2, it will vanish. Now here I have negative 4 and minus 3. So negative 4 minus 3 is what? Negative 7x squared. So I have here negative 7x squared. Good. Now, remember I have my 4, so plus 4x, and then I have my 5 plus 5. Now my next step is to pick the x again and check the number of times it is going inside this guy. So x will go here minus 7x. So here minus 7x, because negative 7x times x is what is going to give you negative 7x squared. Good. Good. Now, if I have minus this x goes into this guy, minus 7x. Now, I multiply through by the minus 7x. Good. So negative 7x times x is giving me negative 7x squared. X squared. Now, negative 7x times positive 2. Negative 7 times positive 2, I have negative 14. So I have negative 14x. Good. Now my next step is to subtract. And then I underline. Yes. So here, negative and negative becomes positive. So plus 7 minus 7, 0. 0, it goes away. Now here I have negative and negative becomes positive. So positive 14 plus 4, I have positive 18x. Then I bring my plus 5. Plus 5. Negative 18x plus 5. Good. Now the next step is to pick this x and check the number of times it is going into this. And it is obviously 18. 18. So plus 18. Because 18 times x is the 18x. Very, 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 very simple. So here I have 18 times x. I have 18x. And then 18 times 2. So plus. Now what do we have for 18 times 2? 36. 36. Good. 36. So here I have 18 times 2. 36. Now I subtract. So bracket, and then I subtract, I underline. Good. Now my next step is to expand. So negative times this 18x is negative 18x. So negative 18x plus 18x, 0. It will vanish. Good. Now this negative affects the 36. So negative 36 plus 5 is negative 31. Negative 31. Now, when I get to this point, I don't have any other variable to make against. So there's no way I can say this x is going inside this a number of times. No, I don't have any other variable. So now I have my remainder because I don't have any other variable again. So this is the remainder. Now this becomes my quotient. That is my dividend. And this guy is my divisor. That is my divisor. Good. So now as the formula goes, now dividend is equal to quotient times divisor, or the divisor is the same as factor. Quotient times divisor, and it's the same as factor, plus remainder. Good. So once I follow this formula, it means everything I have done is correct. So now our remainder is 31. This is our remainder. Now let's go through the remainder theorem and see if, yes, we are actually going to get the same negative 31 again. Negative 31. So now remainder theorem. Remainder theorem. So with the remainder theorem, what we need is the factor. Now the factor is the same as the divisor. So in the remainder theorem, we need a factor. It's the same as the divisor. So in the question, it says find the remainder when 2x cubed minus 3x squared plus 4x plus 5 is divided by x plus 2. So now our factor is the x plus 2. So x plus 2 is our factor. It's our factor. Good. Now, to use the remainder theorem, you need to equate the factor or the divisor to 0. So I have x plus 2 is equal to 0. Good. Now I find the value of x. So if I have x is equal to negative 2, because I'll pick this 2 and then it will cross the equal to sign, it becomes negative. So x is equal to negative 2. Good. So now, according to the remainder theorem, all I am doing is I am going to write the dividend. Now the dividend is 2x cubed minus 3x squared plus 4x plus 5. This is the dividend. So for me to determine the remainder using the remainder theorem, wherever I see x in the dividend, I am going to replace it by a negative 2. And then I find the total. Automatically, I should get the remainder I had when I went through this long division, which makes it very, very easy. Section A, you are gone. So let's see. So now I have 2 into bracket negative 2 cubed minus 3 into bracket negative 2 squared plus 4 into bracket negative 2 plus 5. Now let's see if we are really going to get negative 31. Let's see if we are really going to get negative 31. So now what do I have for negative 2 cubed? Negative 2 cubed. Now because the power is an odd number, automatically we are going to get a negative number. Because when you multiply powers, when a number is negative and then the power is an even number, you always have a positive. But when the number is negative and the power is an odd number, you always have a negative. So I have negative 2 cubed. Now I am going to get negative 8. Negative 8. So I have 2 into bracket negative 8. Good. Minus 3 into bracket. Now negative 2 squared. Because this square here is an even number, it means that we are going to get a positive. So negative 2 squared is 4. Positive 4. So 4. Plus 4 into bracket negative 2 plus 5. So here I have 2 times negative 8. I have negative 16. And negative 3 times 4. Negative 3 times 4. I have negative 12. And then 4 times negative 2. I have negative 8. And then plus 5. So let's see. Now, negative 16 and negative 12 is going to give me negative 28. So I have here negative 28 minus 8 plus 5. Good. Good. Minus 8 plus 5. Good. So here, now, negative 8 plus 5 is negative 3. Very, very simple. So I have negative 28 minus 3. Now, negative 28 and negative 3 is going to give me negative 31. Negative 31. Which is the same remainder when we went through the long division. So now the remainder theorem is telling you that, no, don't go through the stress again. There is a way you can find the remainder easily without going through this whole long division before you are able to get your remainder at the end. Here, no, the remainder theorem is telling you that just take the factor. Take the factor. Equate the factor to 0. When you equate the factor to 0, you have the value of x. Come and put the value of x inside the dividend or the equation that you are dividing the divisor with. When you put it inside, solve for the number. The final answer you get is your remainder. Very, 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 very simple. That is the remainder theorem. Are you okay?
Yes, please.
Yes. That is the remainder theorem. Very, 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 very simple. Very, very simple. That is the remainder theorem. That is the remainder theorem. So we have negative 31. Negative 31. Good. Now the remainder theorem for divisor x minus a. The remainder theorem for divisor x minus a. Now the only thing is, if you have a divisor or the factor to be x plus a. Now the a is any constant. Now in mathematics, any constant is any number. So if you have x plus a number, let's say x plus 2, now automatically the value you're going to get will be negative, because you end up carrying the 2 to cross the equal to sign to the other side. So if, let's say, your factor is rather x minus 3, now it means that the number you're going to get will be positive, because you just pick the negative 3 and cross it over to the other side of the equal to sign. Very, very simple. Very, very simple. So that is how it is. So now we can now formulate the following expression, where f of x is a polynomial whose quotient is q of x and whose remainder is r, when divided by x minus a. X minus a. This is just an expression. It's not anything difficult. They are telling you that x minus a number, like what we had, x minus 1. So this is the dividend. F of x dividend is equal to q of x quotient times x minus a, which is the divisor, plus r, which is remainder. Very, very simple formula. So if we were to substitute x is equal to a in the above expression, then our result will be equal to the r. Now the r is our remainder, just like what we did. So the remainder, when the divisor x minus a is divided by the polynomial f of x, that is the remainder theorem. So we are now able to state the remainder theorem. So the remainder theorem states that if f of x is any polynomial, any polynomial, the f of x is the dividend. It can be f of x, it can be h of x, it can be g of x, it can be a of x, it can be u of x, it can be y of x, anything. So if f of x is any polynomial, and then f of x is divided by a factor or a divisor, x minus a, then the remainder is f of a. Like we did the other time. If I say, for example, if I say f of x is equal to 3x plus 4. F of x is equal to 3x plus 4. Now, when I tell you to find f of 2, it means that wherever I see x, I am going to put 2 there. That is f of 2. Very, 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 very simple. Very, very simple. So f of 2 is 3 into bracket 2 plus 4. That is f of 2. So that is what this theorem is telling us. So if indeed we have a factor x minus a, now here this f of 2 is the same as x minus 2 is equal to 0. This is the factor I had the f of 2 from. So what I'll do is I'll pick the negative 2, cross it over, so f is equal to 2. That is how come I was able to find f of 2. So the validity of this theorem can be tested in any of the equations above. For example, when 3x squared minus x plus 2 was divided by x minus 1, the remainder was 4. So when we use the remainder theorem, we are definitely going to get 4. Now, try this example for me to see. The example 2. When x cubed plus 12x squared minus 3x plus 4 is divided by x minus 2. Now use the procedure to find the remainder. And let me see. They've already given you the remainder here, but then I want to. Did you get the equation? Did you get the expression? Did you get the expression? X cubed plus 12x squared minus 3x plus 4 divided by x minus 2. Find the remainder. Find the remainder. And let's see. When you are done, let me know. Kobe, how is it going? Kobe. Kobe. How is it going? Hello? Hello? Kobe. Hello, Kobe. Hello? So I guess we are going to continue with the factor theorem on Saturday. So don't worry, I'll call you. I'm trying to reach you, but I think you are not answering. Okay. So bye-bye.